And they showed me a blue solution. No, the blue solution isn't it. Just centrifuge and look for that translucent precipitate. Okay. All right, so after aluminum, what ion are we doing? Calcium, was it? Nickel? Chromium? Iron? Actually, iron we finished, aluminum we finished, so it's got to be chromium is the next one, right? And so let's go through the observations and equations for the chromium ion test. And so if our unknown contains chromium, then the first step of the procedure is to add the HCl. With chromium, we should get no reaction. And that is, if we have chromium ions present, they aren't going to precipitate out with chloride, nor will they go from stronger to weaker acid, etc. So that's it. In the next step, we add our ammonium buffer. And so we'll take our solution from 1 plus the ammonium. Buffer, and this gives us a, for chromium, what color precipitate do we expect at this step? No, the yellow's down the road. This is back near the beginning. Not white. Aluminum is white. Iron is rust. Rust brown. So you got white precipitate, you got rust brown precipitate, and you have a what? No, not a silver precipitate. Gray-green precipitate. And so we should get a gray-green precipitate here. What that gray-green precipitate is if we have some chromium present, we'll precipitate out the hydroxide using ammonia and water. So 3 ammonias, 3 waters. This is going to produce chromium 3 hydroxide, which is insoluble, and 3 ammoniums. Okay, then what do we do with this? We add the what to the precipitate?
Sodium hydroxide.
Yeah, sodium hydroxide. So we're going to take the precipitate from 2 and add sodium hydroxide to this. And what should happen? Well, this might be a little tricky because it's in between the lines, but we get no reaction here. Does the precipitate dissolve here? No. And so we're going to have chromium 3 hydroxide solid plus hydroxide. And we get NR. This would have been attempted, let's say, a Lewis acid-base reaction where hydroxide might try to attack this as a ligand. But it didn't happen. 4, we'll take our precipitate from 3 and then add what to it?
HCl.
Oh, not quite yet.
HCl. I mean, hydrogen peroxide.
Yeah, those hydrogen peroxide. Hydrogen peroxide, did that eat away the precipitate? Yeah, actually it should. All of the precipitate should dissolve. This is what you're looking for. And we should be left with, all the precipitate should be dissolved and we should be left with a, what color solution? clear, yeah, but what it's going to be clear colored solution. So clear green solution or clear yellow solution.
Is it supposed to be yellow?
Yeah. It'll precipitate dissolve, leaving us with a CYS or clear yellow solution. So we could just say yellow solution. And so what's the reaction that's going on here? And that is our precipitate is chromium hydroxide, and we're reacting this with hydrogen peroxide. What kind of reaction does this look like? It's going to be. If you think about a chemical property of hydrogen peroxide, what stands out the most about hydrogen peroxide? It's what? Redox, yeah, redox. You would recognize hydrogen peroxide as a pretty strong, not reducer, pretty strong oxidizer, yeah. And I would expect some kind of redox reaction to occur here. And we know this. We know what the distinctive yellow color is. You know what that yellow color is from? What gives the solution a yellow color like this? Chromate. Do you see it on your flow chart? We should have chromate in solution here. And so in other words, you know, something happened. Chromium went from chromium 3 hydroxide to chromate. Is this redox? Well, let's take a look at what happened to the oxidation state. Take a look at the oxidation state on chromium. What is it here on the left? It's +3. On the right, it's +6. And so we went from +3 to +6. Something took the electrons. What took the electrons? Hydrogen peroxide. So hydrogen peroxide is our oxidizer. This must be our reducer here. We don't have to label these just yet. But this is not a balanced chemical reaction. What we want is we want a balanced chemical reaction. So what we're going to do is we're going to use the methods in chapter 5. And so we'll go from chromium 3 hydroxide to chromate. Except I'm going to do this quickly since, you know, chapter 5 is Chem 1A. You've probably done a lot of these already. The chromiums are balanced, the oxygens aren't. So over here we have 4, over here we have 3, so I need 1 water. And now I have 4 oxygens. And then the hydrogens, I have 2 plus 3 is 5 hydrogens. And so I need +5 hydrogens over here. And then the charge, so I'll need 5 electrons here. And so the balanced half reaction for this should be chromium 3 hydroxide solid plus H2O liquid gives us chromate plus 5H plus 5 electrons. Let's check to make sure it's balanced. Here, 1 chromium, 3 oxygens plus 1 is 4 oxygens, 5 hydrogens, and the charge is -2. Charge is not balanced. I screwed up the charge balance. Do you see that? Because over here it's 0 and 0. Over here it's -2 plus 5 is +3. +3 minus 5 is -2. So I screwed it up. So how can I fix that? It should be not +5 electrons. It should be +3 electrons. Okay, now it's going to be balanced. It should be 3 electrons. And -5 plus 5. So this is the reducing agent here. And the reducing agent gives up electrons. We know the conjugate relationship. So if we go backwards, this must be the oxidizing agent, which is taking electron, in this case 3 electrons. And so we can figure out the conjugate pairs here. But what about the hydrogen peroxide? Well, with hydrogen peroxide, it's just hydrogen and oxygen, so this is naturally going to balance following this technique. So we got hydrogen peroxide is going to go to blank. And so we just balance it. We have 2 oxygens, so it must go to 2 waters. And that gives us 4 hydrogens here, 2 hydrogens here, so we need plus 2 more H pluses, plus 2 electrons. And so that should balance this out. So we're going to have hydrogen peroxide plus 2H plus 2 electrons yields 2 waters. Okay, then we'll just add them up. This 3 electrons are being produced, 2 electrons are being consumed, so we'll multiply this one by 2, and we'll multiply this one by 3. And that should get the electrons to balance. So let me add them up over here. So we're going to have 2 CrOH3 solid plus 2 waters plus 3 hydrogen peroxides plus 6H plus 6 electrons. The 6 electrons are going to cancel, so I'm not going to write those there. This is going to go to 2 chromates plus 10H plus the 6 electrons which canceled plus 6 waters. All right, looking at this, this would be my oxidizing agent, and water's got to be my reducing agent here. All right, let's simplify this a little bit here. I have 2 waters here, 6 waters here, so let's change that to 4. I have 6 H pluses here. I have 10 here, so we'll change this to 4. Okay, that looks to be it. So, let's rewrite this. We're going to have 2 chromium hydroxides, chromium 3 hydroxide solid, plus 3 H2O2. We're going to produce 2 chromates plus 4 H plus 4 H2O liquids. And so we should just check to make sure it's still balanced. 2 chromiums, 6 oxygens, plus 6 is 12 oxygens. That's 8, plus 4 is 12 oxygens. 6 hydrogens here, 6 hydrogens here. That's 12 hydrogens. 4 plus 8 is 12. And so we're balanced. Then the charge. Minus 2 times 2 is minus 4, plus 4 is 0. So 0 and 0. Good. There's a driving force for this reaction. The driving force is, this is our reducing agent, this is our oxidizing agent. Chromate and H plus, this would be our oxidizing agent going backwards, this would be our reducing agent going backwards here. And we know it's got to go stronger to weaker, otherwise this reaction wouldn't occur. This reaction did occur, and so we have driving force. Okay, what's next? Oh, no, we're still working on this one. Not yet. Ammonia. or do we add acid first? Do we add HCl? Okay, the situation here is that we just added a whole bunch of hydroxide in this mixture, and then we added the hydrogen peroxide. Therefore, the mixture is actually quite basic because all that unreacted hydroxide that we put in there didn't react. And so, which means I have to do an extra step. This equation is good for acidic or neutral. It's acidic or neutral because we have H plus there. But if we have lots of hydroxide present, then the hydroxide will immediately attack any H plus that's generated. And so if the hydroxide attacks the H plus that's generated, what does it form? So we'll have plenty of hydroxide around that's unreacted that we added in the form of sodium hydroxide. And as we produce this H plus, it's going to form, instead of H plus, it's going to form water. And so with all this extra hydroxide around, we never formed the H plus. It goes to water. But we screwed up the balance because now I added 4 oxygens and 4 hydrogens to the right side. Well, if I do that to the right side, I have to do that to the left side as well. And so I'm going to go plus 4 hydroxides here. And so overall, the reaction is going to be in basic solution, 2 chromium hydroxide solids plus 3 hydrogen peroxides plus 4 hydroxides yields 2 chromates plus 4 and 4 gives us 8 waters. And so this would be the equation for basic solution, which we have because sodium hydroxide is quite basic. That's going to make the solution very basic. All right, the next step is we're going to add HCl, right? We're adding HCl. We're adding it to this chromate. Because now we should have yellow chromate in solution. So we went from this gray-green precipitate to yellow chromate aqueous. And so chromate has an interesting reaction. If we have chromate, we can convert chromate into dichromate, 2 chromates. But it's not exactly 2 chromates. If you had dichromate, you'd expect 2 of these tetrahedral CRO deals like this. And so if we put 2 of these together, we would expect something like this, where now this, I didn't fill in the rest of the electrons, but this looks like dichromate. You know, I have 1 chromate on the left and a second chromate on the right, and they're linked together by a bond. But there's something about this bond you should know. It's an oxygen-oxygen single bond, and you might have seen it before. Where have you seen an oxygen-oxygen single bond? Well, oxygen-oxygen single bonds occur in things like H2O2. You know, the O2 2- ion, the peroxide ion, has an oxygen-oxygen single bond, which is highly unstable. And so this doesn't form like this. We don't form a peroxide link. Instead, what happens is this. If we're to bring 2 chromates together to form 1 dichromate, it would come together like this, where, see, one of these chromiums would have to lose an oxygen. And so if one of these chromiums lost an oxygen, then the type of link we're going to form is like this. It's going to be CrO, Cr, a bridging oxygen they call it. And then we have the remaining oxygens here. Oops. Yeah. And so we have to remove that oxygen. Well, how can we remove that oxygen? Well, we need a little help. And so the help is going to come in the form of 2 H pluses. If I have 2 H pluses, then an oxygen plus 2H pluses is going to make water to a liquid. And so if I take 2H pluses, react it with 2 chromates, I'll form a dichromate. Now the dichromate is going to be missing 1 oxygen. So rather than having 8 oxygens, it's going to have 7 oxygens because we don't want to form a peroxide bond like this. So Cr2O7, 2 minus, plus an H2O liquid. And so the next reaction we can see here, because if we have chromate and we increase the amount of acid, Le Chatelier's principle says it's going to shift it to the right. And so this is a way to convert from yellow chromate to, do you know what dichromate's color is? Kind of an orange color. And so in acid, as we add more and more acid, it shifts this further and further to the right, which makes more dichromate, and things darken. And so that's what we're doing in this next reaction when we're adding the HCl. The HCl, what was the, what's the number I'm on now? 3? 4? So anyway, we're going to take the solution from 3 and add HCl to this, and the color is going to change to an orange color. The reaction is here, 2H plus 2 chromates yields dichromate and water. And so just adding more H plus here is going to force this to the right, making more dichromate. Okay, what's after this? After the HCl, we want to add ammonia.
Yeah.
Is that right? All right, so to solution 4 plus ammonia, do you know what's going to happen? It's going to go from orange to what color? Back to yellow. One way we can write the equation for this is 2H plus 2 chromates yields a dichromate plus water. So what happens with ammonia? Ammonia is going to react with the H plus. So if there's H plus around, ammonia will take it out. And so here we'll just bump that up to 2. And we'll form 2 NH4 pluses. And so Le Chatelier's principle says if the concentration of the H plus goes down, we should shift the equilibrium back to the left. And so all we're doing here is we're pushing the equilibrium one way or the other. If we add H plus, we push it to the right, which is for dichromate. If we remove H plus, well, how do we remove it? We react it with base. We react it with base that takes out the H plus. Now we're only left with ammonium, which is much weaker. Okay, so this is a kind of a unique sequence that we can do with chromate and dichromate. And so after this, what do we do? Add aluminum. All right. Aluminon? No, not quite yet. Do we add barium chloride next? Yeah. All right. And so 6 here, we're going to take the solution from 5 and then add barium chloride, and we should get what? Barium chromate, right, which is a solid PPT. So the reaction here is that if we have chromate present, that's going to react with barium 2+ ions to form barium chromate. If you go through all those steps and you end up with the barium chromate, which is a yellow precipitate at the end, then you can feel pretty confident that you had chromium in there. All right, the next cation is what? Calcium? All right, why don't you start calcium the same way we did it? And